Hello and good evening, good morning, good afternoon, wherever you might be. The good thing about doing these online meetups is we have people join us from all parts of the world. I guess we should just say good day. Uh, it's December 2021, and this is the Orlando.NET user group. Just a reminder that this meeting is being recorded. So if you do not consent to this recording, feel free to drop off. Uh, so a little bit about us. OneTug is Orlando.NET user group. We also organize the Orlando Code Camp, which we have not had since 2020, actually 2019, because the 2020 event got canceled. But we hope to have one hopefully in the near future. So these are the people behind the scenes who bring you all these events. These are the resources to connect with us. I would say the best place to get in touch with us is meetup.com/onetug or on Twitter @onetug. Upcoming meetings. Do I have Todd in here? Because I think we have a great great guest next. Oh, Todd is on hold. Okay, so we have uh, we're actually working on nailing down our meetup host for the next month, which will be the first one in 2022. I can't believe it's almost 2022. But and we will provide details on our meetup page and social media accounts as soon as we nail down the final details. But I think you're going to like the next speaker. Not that you won't like this speaker, because this speaker is awesome. That's why we invited him. If any companies are interested in sponsoring, please get in touch with us. If there are any announcements, community announcements, please come off of mute and make them. Jamie, if you have any announcements for any events or open source projects, anything, or if anyone else does, feel free to make them now. Like I said, next month's meetup, uh, we'll be announcing that on Meetup and Twitter and other places. Okay, if no one else has anything, let's move forward. Tonight's agenda, we'll have the welcome and announcements, and the talk is being recorded and will be available on our YouTube channel. The YouTube channel is onetug.net/YouTube. And with that, I hand it off to Jamie. Jamie, take it away.
Hello, everyone. So it's great to be here and great to talk about Windows containers and containers in general. Let me share my screen here. Hopefully everybody can see my presentation. So the title of this talk is Kubernetes and Containers for the .NET Developer. This being a .NET users group, I'm going to focus the content heavily that way. It won't be a container talk without talking about both Linux and Windows containers. And I'm probably going to throw a lot of information at you tonight. A lot of this, don't get overwhelmed. A lot of this is to help you have a baseline that if you're new to containers, you can start to understand what's going on there. A little bit about me. So I'm a software engineer on the Rancher Windows team at SUSE. So yes, I am at a Linux company with the Windows team. And our job is to make the Windows experience for Rancher and RKE, RKE2, and Kubernetes in general, the best it can be. I've been 15 years plus experience doing Windows and .NET development. So I've been there, done a lot of stuff from web forms, Silverlight, WCF to .NET Core. I have experience in Azure, and then my background's really kind of more enterprise type development. So I know a lot about those constraints that happen there too. So we're going to start off with a little bit about the history of Docker. So not all this is 100% like, there's some hand wavy stuff here with this, and there's just some high notes. So if you don't know, Docker is like the thing we think about when we think about containers. And the history goes back a long way, actually, back to the 70s with a thing called a chroot in Unix, or a change root. And so in Unix, this was a way to limit the directories that a process had access to. So you could change the root directory that a process is running in. So instead of the process running to where it has access to everything in the machine, you could limit that process to just a particular folder or subset of folders underneath that subset of folders. So think about if you're doing like a PHP website, you could limit the PHP process that's executing the website to just the folder that contains the PHP code. So that's a change root, or chroot is how it's often pronounced. So then we fast forward a couple decades, and then roughly around 2007, we have this thing called C groups that happen in Linux, and these are called control groups. And so the idea of a control group is very similar to a change root, except you're limiting CPU and memory, like system resources that a process can access. There are a lot more details to this, right? There's high level. So then we end up with these things called C groups. We have chroots. Then we fast forward to 2013 in a company called .cloud, which, funny enough, I was a customer when they did their own cloud hosting, their own platform as a service. It was focused around Python. I found it easier to use than App Engine. And then magically, about a year and a half later, they decided they're up and changing their name to Docker Inc. So they've come up with this new technology that we now know as containers, which is really just a combination of chroot, C groups, and a little bit of other stuff. And so those things combined together make Docker the way it is. And really, it's the way they decided to package up those technologies that already existed and make them easy to consume. Because spinning up chroots and C groups requires quite a bit of knowledge, versus you have a Docker file, you get this container, you run it. And so that happened in 2013. So I find that kind of amazing that containers have taken everything by storm, and it's not even been 10 years. So we could also look at this as it's still new and young, and we're still finding things out. And a lot of that can be seen by the fact that we have the Open Container Initiative now with OCI. We're starting to get additional runtimes for containers. So not only do you have Docker, you got Containerd or Cryo. So, there's lots of things happening in the container space, but the history, goes way back to a lot of technologies that kind of came together and were bundled up in a way that was easy to consume. So now that we have containers, we can jump to the history a little bit about Kubernetes. So Google had this thing called Borg about the mid 2000s that they used to do a lot of their service hosting, to orchestrate their services. And if I recall correctly about some of my history, that C groups came out of Google roughly around the same time. So I would imagine C groups were involved with Borg, probably chroots were too. And that became the influence for K8s. We had somebody with a statement that like containers there. It's like kind of probably. I mean, I would consider like BSD jails, just on a little side note here. Solaris, LPARs in Unix land, like that. I think that's very similar in the mindset of containers, right? So, it's yet again, we're high level here, right? But I think your intuition there is kind of correct. With the chat message there, that these things have kind of been around, right? And but how we use them and consume them today is kind of new and young still in lots of ways. So Borg influenced K8s. So Kubernetes kind of open sourced in 2014. The first release was sometime in 2015. So we're only 6 years past when Kubernetes kind of became a thing. So that's something for reference there. And so if you feel like things are still a little rough around the edges or maybe not as easy to consume as you would like it to be, just kind of know that, we're still early in lots of ways. And there's lots of things about if you're coming from .NET, Windows, that are not quite there or in place yet or do things slightly different. And that's why there's typically some lag sometimes in getting features and capabilities that are on par with Linux. So just know that that's kind of a really high level history. But I think this is kind of important stuff to set a tone with this stuff. So the thing we're probably most interested in as a group, right, is the .NET container ecosystem. And the ecosystem really is Linux and Windows. A lot of people don't initially think about Windows when it comes to containers, but .NET being a Microsoft product, having deep Windows roots, there are Windows containers for it. And really, containers in the .NET container ecosystem come in 2 operating systems, Linux and Windows. And it comes with 2 kind of base runtimes, bases, which is the SDK and the runtime. So the SDK is the software development kit for .NET. So think of that when you're doing local development, you want the SDK. So if that would be a container base you would use to compile your application in the container and do all of those steps. There's MS build, all the things you would expect. And then the runtime container is really just the .NET runtime. So it's the stripped down, smallest thing possible that you can drop a compiled application on and execute it. So that's the 2 options you have working with .NET containers, the SDK and the runtime. And then on top of that, Linux and Windows. So now we're going to talk about the Linux containers. So Microsoft officially produces 3 base images with using 3 different Linux distributions. So on the official Docker Hub MCR container registries, you'll find Debian, Alpine, and Ubuntu. Those are the 3 that they publish officially. If you have a different Linux OS that you want to use, then of course you can install .NET on there using the installation scripts you find on the website. You can use the package managers for some distros like Rail or Fedora or SLES, so SUSE Enterprise Linux. But these are the official ones from Microsoft. So just kind of know. And Debian, I have a star there next to it because it's just a little more special than Alpine or Ubuntu. Also note that these go back different versions of the operating system too, right? So it's Debian 10, Debian 11, Alpine 3, .x, Ubuntu 18.04, 20.04. They typically only do LTSs. Or long-term service versions. I haven't seen some of the intermediate stuff there as often. So just keep that in mind. Then we get to Windows containers. So you could see back at the Linux containers, you have 3 operating system versions that are shipped with multiple. You have 3 operating systems that are shipped with multiple versions. But then when we get to Windows containers, this turns it up a notch because Microsoft produces 4 base images per Windows Server version. So all of these 4 exist for both 2019 and 2022. Notice that I'm only using 2019 and 2022. That's because Microsoft has made a shift to do long-term servicing channel, or LTSCs. And so a lot of the intermediate stuff that you might know is like 1904, which is now out of support, 1909, which is out of support, 20H1, I think goes out of, or 2004 goes out of support this month, I believe. And then 20H1 will be next fall, roughly. So those are kind of dropping. And so, you don't using those for your container images means that you'll be unsupported, if you were to use one of those versions. So 2019, or sometimes called 1809, and 2022 are the versions of server you want to use. And then inside of those versions, there's multiple base images to choose from. So we'll go over those differences, and you can already see here, I'm starting to show more differences between Linux and Windows here. And I think that's important to understand in the .NET container ecosystem. So Nano Server, that would be the container image you would want to use if you were doing .NET Core. That's kind of the focus there. It's not full 100% Windows API. There's a few things missing. It is also the smallest at 300 megabytes. There's no PowerShell shipped, so you can't just run a PowerShell script. It's not there. WMI GPU support if you're building a .NET Core app that wants to do something with the GPU. That's not going to happen with Nano Server. A thing to note is you often hear that Windows containers are much larger than Linux containers. When you compare Nano Server, a runtime, to a Debian runtime, they're not all that different. I think it's like 50 megabytes. So it's not till you get to the other base images that it starts getting much larger. There's Server Core. So this one ends up being the one that you end up using a lot because it comes with PowerShell, and I'm going to call it Legacy PowerShell because it's not PowerShell Core. It's the place to start if you're trying to do .NET Full Framework. That's the only thing they offer is Server Core for .NET Full Framework. Legacy apps or things that need a richer Windows API support, Server Core is good for. Yet there's no GPU support. So keep that in mind, that if you need that kind of functionality for your .NET application, you'll want to use Windows Server. And you can see here, 300 megabytes, roughly 1.1, so it tripled to almost doubled, to 3.1 gigabytes, so it tripled again in size. So this would be full Windows API support, all your server features. This might be a good sweet spot for legacy applications if you have .NET Full Framework apps that you want to port to Windows Server that have some deep integrations that may require some Office things or whatever. And then you get GPU acceleration and support. So that's good to know, because those are key areas where you're going to focus if you're trying to take a .NET app and decide, am I doing Linux? Am I doing Windows? Am I going to need those features and those feature sets? And that's going to really narrow it down for you. And that's the thing. A lot of people, I think, want to jump to Linux containers immediately with .NET Core, but you don't end up running into like some of the odd stuff, which it won't be odd once I talk about it. And then you have things like Windows. So this is the largest. It's really huge. It's got GDI support. So if your .NET application does something with GDI, which I'm sure there's plenty of legacy applications people have that do that, just know that you would have to go with the full Windows image. There's not as many server features or any server features there, but there's the full Windows API. So you could kind of think about this as Windows Desktop, but it's not really for running GUI applications per se. So keep that in mind. So a thing to think about is with Windows containers, I get asked this question all the time about like, I'm spending a lot of time talking about Windows containers and, why would I use those with .NET Core and with Linux? One of the big things is Active Directory integration. So Active Directory integration, last I've checked, doesn't work on Linux, especially for a .NET Core app, or .NET app. So if you need Active Directory integration, you're going to want to use a Windows container. And there's some special setup there in a Kubernetes environment for that with GMSA or Group Managed Service Accounts. So that's something to keep in mind. If you need Active Directory integration, you're probably going to end up using Windows containers. If you can't, like, switch to LDAP, which should work. If your app is using any of the Windows namespaces, I believe that's what they started calling them in .NET 5, .NET 6. They started breaking things out better. Might have been in 3.1. Or you're using Linux namespaces, then that's kind of going to drive your container decision. So keep that in mind. Cross-platform containers. So this is kind of a funny thing to call it because there's no such thing as a cross-platform container. But what you can do is you can build multiple containers for each platform that you target, and then you publish those in a manifest. And then that manifest, when Docker or Containerd or Kubernetes requests that image, it will say, here's my operating system, here's my platform, so AMD 64 or ARM, and here's my version if it's Windows. So then your manifest, it will look it up in the manifest to determine what container image it should return to you. So if you look at mcr.microsoft.com.net SDK 6.0, that is pointing to a manifest that lists both a Linux AMD 64 container image and a multiple Windows container images actually. And note that the SDK 6.0 tag or the 6.0 tag defaults to using Debian for Linux and Nano Server for Windows. So that's important to know because that's going to tell you what's available by default with that tag. And so hopefully you can see the Docker Hub here for .NET. So this would be core. You can see here there's links to the different things that they produce, the important ones. ASP has its own for the runtime. There's the regular runtime. There's the SDK. If I click on one of those and go in here, you can see here that the default tag, if you were to pull current or latest, would be 6.0. And that tag is here at the end, which is pointing to Debian Bullseye, so Debian 11. And then if we scroll down, 6.0 points to Debian Bullseye for ARM64 V8. There's ARM32 versions. Then we get into the Windows versions. So you can see here, Nano Server 2022, Nano Server 1809 they've added LTSC 2019 now. So you can see here that actually 6.0 does not default to that one. It defaults to 1809, which is the same. But so knowing how to read these tags, especially when it comes to a manifest that's going to show up here, is very, very valuable to realize that one tag can point to multiple operating systems and multiple architectures. And I'll do a demo of that in action. And then, of course, there's .NET Framework. This is the SDK. There's 4.8. There's 3.5. These things are out here. They got some other bases outside of just runtime and SDK. But in general, WCFs out here, things like that you're going to need. So 4.8 points to LTS Server Core 2022, 20H2. There's no Nano Server if you look through here. This is all Windows Server Core. And so that's kind of good to know. And then there's tags for older versions too. Just know that they're all out here, and this is kind of how you scroll through and read this. So the next thing I wanted to do is I'm going to stop sharing this screen, and then I'm going to share a Docker file. So here's my Docker file for an app that I've built. This is a multi-stage build. So what I do is I use one container, the SDK container, to build my .NET project. And then I copy that DLL, the compiled app, into the ASP.NET runtime container. And then I execute it. So, or set my entry point to execute it. So what this does is I build with the SDK, which is much larger, and then I copy the output to a smaller image for deployment. So that way it'll be able to be downloaded quicker and executed quicker. And so you can see here, this is just 6.0. I have my Docker set to Linux containers right now. Let me double check that here. If you have questions along the way, just ask. I'll try to answer them. So I have my Docker set to Linux containers. So if I run this, you'll see that I'm getting the fancier Linux output. Of course, all this is cached. So I can, if we want to see it actually in action here, let me just ignore the cache. You can see here that it's going to go and start copying the things, my code into the container, and doing the restore on the solution file, and then it will do the compilation. And then when that's done, the container, that image that I end up with, will be based off of the ASP.NET runtime for 6.0. So there, it's finished. So there are special IIS images in Docker Hub, which references back to MCR to pull if you need IIS. So that was a question, is which images support that? I'll pull it up here, so I'll have to Google this because I don't have it offhand. So Windows IIS container images. And you should be able to find most of this stuff here, like the Docker Hub link. And you can see here there's 2019, 20H2, and 2022. So you can see they're already starting to get rid of the SAC versions and just do the LTSCs. So these would be those, and then you can scroll down to the tags that would be used. These tags typically don't have the shortest handle, like latest here. Now, well, they got the different versions, but in general, it's just not the same structure as the .NET ones. So
you're not sharing your screen.
Oh, sorry. Let me switch. It's a problem with the ultra wide monitor. Thank you. Okay, so I just Googled Windows IIS Docker Hub. I found the page. You can see here they mainly have the LTSCs and the 20H2, which is still in support till next fall. And then they have the commands to pull these, so you can just call IIS, which will pull latest. And you can see here, this is what they have. One thing of note here that I haven't noticed, this is a little bit, it's been out there for a while. They have these multi-architecture images, which I think is kind of interesting. But I think that's because, so they got the OS. So this is an example of one that's a manifest. So latest here will pull, depending on version, this. And these actually go back to 2009 and 2016, which is interesting note there. I have to look into that. So don't try that. I wouldn't, anything older than 2019, I wouldn't try to use. I think containers started getting support in 2016, but I guess that's 2009. That's how I should read that one. This is, I don't know. I'm getting distracted now. Interesting tag. We got an interesting thought experiment there with that question. So let's go back to the Docker file though. So I have 6.0 tag. I just built a Linux container. I'm going to switch my Docker desktop to Windows containers. And you would think, oh, well, you might need to switch information up here. I don't, because remember, 6.0 points to a manifest, which contains multiple operating systems, multiple versions of the operating system, if it's Windows in this case, multiple architectures. So now you will notice when I run a build that the output is different because build kit's being used on Linux, not being used on Windows. And so the output's going to look like what you're probably used to seeing with Docker up until they made the switch. So if a manifest is provided that supports all the things that you need to support and you don't have a special case, then I would recommend when you're writing your Docker files, use the manifest because it'll execute the same across the operating systems, which is really a good advantage on a team if people are using Mac or Windows or even Linux. With that said, if you need to use like Alpine or Ubuntu, you're going to have to include that tag instead of the 6.0 because 6.0 references the Debian Linux in the manifest. So if you have the need to use something different that's not the happy path, then just know that what we do to handle that often is we'll make an argument and we'll just say version. And then you can substitute that in here, and then you can pass that in on the command line what version you want to use. So you can do that too. So these can be parameters that you can pass to them. But in general, sticking to the manifest, I think, is a good strategy to start out with. Okay, so let's go back to the presentation now. So another thing that you got to keep in mind when trying to adopt containers or integrate containers into some app you have, whether that's a new app or a legacy app, is what I'm phrasing as container ready. You know, is your app ready to be containerized? And really, this comes down to doing a dependency inventory. A lot of people don't have these for their applications. I think it's a really pretty interesting technique to really figure out how to containerize your app. And it really starts with documenting software that's required, APIs that you use, if there's any OS specific APIs or libraries that there is not, you know, there's only a Windows or only a Linux version. If you have AD integration, like I talked about earlier, that's really going to determine the container platform or operating system that you kind of base it on, whether you do Linux or Windows, is going to be those things. It's also going to highlight if your app will even work in a container. So in the example of a legacy application, I've had some software that the app depended on that could only be installed with a GUI. So that comes down into your automated deployments to a point. Can things be automated? Because if it's a GUI only install to configure some DLL on your system because you got to input a license and you can't, you know, find the register keys that need modified or generate whatever binary file that gets encoded, then you can't really stick that into the container, right? Because you can't run that in a Docker file. Are your deployments automated for your app? You know, can you automate the deployment of this? Because if you can't automate the deployment or automate the build, it's going to be really hard to stick it in a container. I mean, you're going to be doing this manually. And that's not a good strategy. So do you have CLI apps? Big advantage with Linux is traditionally there's a lot more CLI capabilities with Linux. So if you need those things, or say you have some automation or tooling built around PowerShell and it won't work with PowerShell core, then you're going to use server core, right? Because that comes with legacy PowerShell. Probably shouldn't call it legacy, but that's what it's going to come with. So that's kind of going to drive your choice. And as a .NET developer, you got a lot of choice. So that's a good thing, right? You have Linux and you have Windows, and you have multiple versions of Windows. So that's the things you're going to have to think about to be container ready. Is, do you know what you need in a base image? Can your stuff be automated? Can you install stuff in a headless fashion or with a CLI to be able to put that in a Docker file? And the good thing about creating Docker files and moving things to containers, even if it's just for local development, it's documentation, right? You don't have to have a new developer install the things or a new person on the team. You just say, pull down this container, do this, and one simple Docker build command, and you can build a working application. That's a big advantage in lots of ways compared to traditionally reading a wiki page with how to set up your dev environment locally, and then you find out things don't work, or you hose the system, you have to have it fixed. So that's all part of the adoption, and that's generally what I recommend people is kind of start with your development workflow, local testing, local stuff. Get familiar with the technology, get familiar how you're going to deploy it. I think that's part of getting in this mindset of using containers and things like that. So this is a quote from an episode of .NET Rocks. If anybody remembers which guest said this, the quote stuck with me. Unfortunately, the episode in which it is in, I cannot figure out. But the statement was, are you currently doing DevOps? If not, containers will eat your lunch. And I totally agree with this statement, because if you don't have these things automated, then how are you going to patch your container if there's a Windows CVE or a Linux CVE that you need to get up to date? You're going to have to build that container by hand again with a fresh image, with the CVE fixed. So you're going to have to figure out how to keep these things up to date. And I know with a lot of applications, people can deploy those, and if you're in Azure, you don't really have to worry about the platform. It's auto updated. If you're for past services anyway. If you're running on-prem, you're running Windows updates on a schedule. Your operations team's doing the system maintenance, both Linux and Windows. But you're not going to have that in a container, right? You're deploying a container at a fixed point in time. It's immutable. And so if you want patches, you want updates, you're going to have to rebuild the container and deploy it again, whether your code changed or your code didn't change. And that's something to think through, is that if you don't have CI, you're not automating the builds of these, then you kind of really need to think through that and make sure that you have a good process in place to get these things out there published and updated. So nuances of Windows containers compared to Linux. These are important to know, because this could drive part of your decision. First of all, is your operations team, are they comfortable with Linux, or are you primarily a Windows shop? That's the things you're kind of going to have to ask, because that might make the decision for you that you're going to be more, you want as few Linux hosts for running containers as possible. So you really don't want to deploy on Linux, because your support staff, your operations team are not going to be familiar with it. So that might drive some of the decision-making process here between those. And then another thing to keep in mind about Windows and Linux is licensing support. A lot of people like to run Linux because you don't have to pay for licenses and licensing like you do with Windows. A lot of enterprises, on the other hand, like having licensing and licenses because then they have support. They have somebody to call. If you're going to deploy Linux hosts and you're going to want support, then you're going to be going with SUSE, Red Hat, Canonical, someone like that to get Linux support. And so that's going to partially drive some of your behavior. Now, I don't know policies around some of that stuff, but I can say, no, you cannot host a Windows application from a Linux container, a Windows form. Nope. You probably could with Mono, but that question come in. I think that's a good question here while we're talking about that. Yeah, but that would be unsupported, right? So I don't think web forms works on Mono though because of the system web stuff that's required. So that's just something to keep in mind. So you're going to need support, and like say you have SQL Server and you want to containerize SQL Server. Well, SQL Server for Linux only runs in containers that are Ubuntu or RHEL. I think they might have SUSE. I'm not positive there. And Microsoft's official policy in the docs is that if you're running an Ubuntu SQL Server container, it needs to be running on an Ubuntu host. Most Linuxes, you can mix and match the container host versus the container OS versus the host OS. Just know with things like SQL Server, if you're going to containerize that and run it, that's going to drive your choice of host for your deployment environment. So keep that in mind, that there's some of those things. So I'm covering probably a little bit more Linux nuances here, but just know that there's lots of things go into this when you start talking production, support, things like that. So nuances of Windows containers compared to Linux, that's some of them. The big one though is, you can run a Debian container on a RHEL or a SLES host. So that's SUSE Enterprise Linux. Or you can run it on Alpine or whatever. It's generally cross-compatible in that way. Windows containers are not. So the container OS version must match the host. So if you have a container OS version 2019 LTSC, your container host needs to be 2019 LTSC. There's a little bit of wiggle there for like minor versions, but in general, they need to be the same. So if you're running 2022, you have to have a 2022 container. There's just no way around that. And that's why you see in the manifest there multiple versions of Windows, because you need to be able to pull and support the Windows versions that people are running. A lot of that comes down to the fact that Windows containers use process isolation on the server. Process isolation requires the kernels to be very close to the same. Hyper-V isolation, the capability to use that is coming to server, and that's what you currently are using on Docker Desktop on a Windows like 10 or 11, and the reason why you can run an 1809, 2004, 20H1 container on a Windows 10 host, right, is because of the different types of isolation models going on between that and server. An interesting note, though, is if you have 2022 in your environment, or you're looking to run Windows Server 2022, note that it's hard. You have to be on 21H1 Windows 10 to run the special 2022 Windows 10 20H1 container. If you just want to run the straight up 2022 container, it's best to upgrade to Windows 11. You can run 2019, you can run 2022. So that's some small things to know if you're on Windows, that's going to come into play. Continuous integration pipelines. So along this idea of nuances, who cares what version of Linux they're running? As long as I have Docker, I can build my containers all day long. It works. Not the case with Windows, because the host has to match the container version. So unless you're running like desktop, which yet again, you run into some other nuances because of manifests. You will need to be doing your CI on a Windows Server 2019 if you want to build 2019 images. So same thing for 2022, you'll need a 2022 runner. This gets easier now that Microsoft's moved to just 2019 and 2022. They're letting 20H1 kind of go out of support. Well, support long before it was created was set to be in next fall. So they're not keeping with that model. This makes it a lot easier. But if you're trying to support multiple, like 4 or 5, like we do on the Rancher side, then you got to have CI runners for all of those. So just know that that's something that you're going to have to count for. So if your CI system doesn't support the version of Windows you're trying to build a container for, you might have to find a different solution. So that's just kind of where that's at. Multi-version support requires a Docker manifest. So if you're going to run or ship your containers to customers or to third parties, or you're building a chart for your product to sell for Kubernetes, and you want to support Linux and Windows with your app because you're doing .NET Core, then ideally you should be making a Docker manifest that's like your core version, and then you have images for Linux and Windows specifically rolled up in there. Yet again, I say it again, the hosting environment needs to support the Windows version that you're trying to build. So, if your IT department only has Windows Server 2019, you need to be building 2019. You can't build 2022. A caveat here is if your IT department or your hosting only has 2019, but they're going to migrate to 2022 sometime in the future, I would encourage you, when you're setting up your pipeline up front, add in 2022 support from the start. You don't have a bunch of versions, but having those two things there is going to make it a lot easier. So when they want to start testing 2022, you already have it, right? You can say, oh, just deploy this workload to my Kubernetes cluster or whatever I'm doing to orchestrate it. Here's 2022 image already. So that's something to keep in mind when you get into your continuous integration, is that you're going to have to think about this a little bit more, especially if you're trying to be cross-platform, as in support Linux and Windows with your app. I haven't talked a lot about Kubernetes development, and there's kind of a reason why. I'm saving this to the end, and that's is because Kubernetes is containers, right? And you need to have a good grasp of the dynamics happening in the container ecosystem, what the base images are, getting comfortable with the technology, and kind of having a pretty good grasp on that before you jump into Kubernetes. Kubernetes development, really, you're just writing some, I'm going to play this down a little bit, but you're basically writing some YAML to deploy some container images, right? Defined with some characteristics on how those need to run. If you're familiar with doing Docker and Docker Compose, there's some tools. I think the tool is called Compose with a K, that will convert a Docker Compose file to Kubernetes manifest for you. So if you want to start testing these things out and learning Kubernetes, that is the way to go. I'm big on having local development environments and being able to test things locally, because it's quick feedback. And so there's some caveats here. Currently, there isn't a good solution for using Windows containers in like a local environment. And even if you could just, I think you can use Docker Compose with Windows containers. At the end of the day, my personal opinion is that's probably not super useful for Windows development, because if you got a complex Windows app, you might be running SQL Server in a container, you need Linux. You might be running Redis in a container. Well, you need Linux. And so what you really need for a good, rich Windows local development environment is something that can support mixed workloads easily. And currently there's not a solution there other than spinning up your own Kubernetes cluster with full VMs and things for doing that. However, to get comfortable with Kubernetes, there's quite a bit of solutions that you can use on your desktop. These all work Windows, Mac, Linux, but they only do, well, Windows and Mac. Linux, you can get straight up Docker, right? But that's not going to do Windows containers, and none of these solutions will do Windows containers at the moment. And so for dev environments on Windows and or Mac, you could run something like Rancher Desktop. So that's a tool we are making that runs on WSL on Windows, that allows you to do a Kubernetes development environment locally. It also has some tools in there for building some Linux images and things like that. NerdCTL, which is a tool that leverages Containerd. So you can do some of these things there with Containerd with NerdCTL. And then Docker Desktop, of course. Docker Desktop has in the settings a check marks to enable Kubernetes. So it will spin you up a Kubernetes cluster. I believe it uses kind, if I recall correctly. So you can do that locally, right? One thing kind of faced with Docker Desktop is the whole licensing change that happens at the first of the year. If you're not aware of that, Docker Desktop is changing its licensing model that, it'll remain free for personal use, but, for business use, there's going to be a fee, right? $60 a year at the base price. But just keep that in mind that those changes are coming. So there's lots of active development in the NerdCTL Rancher Desktop phase for doing some of this stuff. And then other options, if you want to spin up a small Kubernetes cluster, there's K3s. So that's a lightweight Kubernetes distro. There's K3D, which is spinning up K3s in Docker. So inside of Docker, you can build your own Kubernetes cluster inside of containers. It's kind of cool. Kind is the same way that's listed here. So Kind is Kubernetes in Docker. So that's a very cool project. Minikube, which is officially supported by Kubernetes, I believe, for doing testing and stuff. Kind is used in testing too for Kubernetes. And then things like micro K8s from Canonical, you can install that on Ubuntu, or you can use a thing called multi-PaaS on Windows that will, and I believe there's a Mac version now too, that will spin up a Ubuntu VM under the hood and then pass through the micro K8s command line. So you can do micro K8, which is just a self-contained single node Kubernetes cluster, much in the same idea of like K3s or Minikube. And then it kind of ships with all the tools. So you can execute a lot of those things locally. There's multiple ways to get there. And that's a whole lot of stuff to talk about. So I'm kind of going over that pretty quick, but understanding the container side is really important, and kind of the layout and how things are to start ramping up with that. And we're to questions. So which of these environments enable, okay, so we've got another question in the chat. That's probably a good place. Which of these environments enable Windows containers other than Docker Desktop? NerdCTL has some early support for Windows containers running on Containerd. One of the Windows special interest group leads for Kubernetes has been submitting a lot of PRs, pull requests to that project to get Containerd working better as a local Docker desktop style tooling. And part of that Containerd comes in NerdCTL working there. So that's kind of what it is. Like right now, really, Docker Desktop is the thing. NerdCTL is trying to have a Docker file compatible solution or API, so you can define a Docker file, run the same commands as you would with Docker to build a Windows container. There is a cool project called Crane that's part of the Google Container Registry. Hopefully you all see in my browser. Let's see, not the Go Container Registry. Here on GitHub. Yes, Rancher Desktop is free and 100% open source. So Go Container Registry has a tool in here called Crane, which allows you to work with images. And I've submitted a PR to have it respect Windows versions. So not only can you pass Windows, AMD 64, you can also pass a version. So you can do 2022 or 2019. And you can use Crane to actually build Windows container images. There's some caveats there though. So to do that, you have to pass it pre-compiled binaries. So if you do a publish to get libraries from your .NET Core app, you can then tar those up, and Crane will add that, will take that tar file and create a container image layer, and then you can modify the entry point and you can create an executable container with your app in it without using Docker at all. But it does require you not to do multi-stage builds and things like that. This is taking, compiled output and just sticking it inside of a container. And that's pretty cool because you could even do that from Linux. So I have a blog post on my blog about building .NET Core 2022 server images on Linux with Crane. So you can do this in WSL with Crane too, or you can do it. I mean, all you need is Go. You can run the command. You can get Crane, and you can just execute it on Windows too. So there are some workflows, but you lose the Docker file, right? So anything like you're enabling a Windows feature or Windows Server feature or something like that, you don't have that capability. So this is really just placing files on the file system and then telling it what to execute. So it's some limited scope there, but it is a solution depending on your workflow. And since we write a lot of things in Go, they have a project called K-O, I think it's pronounced Co, that does this for Go binaries. And that's really cool too, because if you have a big CI infrastructure to support Windows, if what you are doing fits the use case of Crane, then you only really need a Linux CI runner. So that really reduces a lot of stuff there. We got any more questions? Thank you for the comment. This is a deep subject. Yep.
Yeah. So great talk. So my question was, I'm trying to narrow down like the use cases, right? Because obviously, Windows Form, those type of applications you said is not possible. So is this like, are we talking about things like websites and web services exclusively that are like legacy.NET or something like that that may be a good fit for Windows containers? Are there any other types of like workloads you can think of that might be,
Yeah, I mean, the sky's the limit when you start talking Kubernetes, right? Like you have jobs in Kubernetes. So if you had things that need to run on a timer,
console apps.
Yep, console apps, you could deploy those in a container, and then you can just let the Kubernetes scheduler schedule those for you, right? If you need a daemon to run, you could deploy your console app or your thing as a daemon set in Kubernetes, and you can tell it I always need 1 or 2 workers, or 2 pods running all the time in this daemon set, and it will make sure there's always 2 running. If one gets sick, it'll destroy it and spin up a new one. And so you could use this for running console apps, for running ML workloads that are maybe in ML.NET, processing things. There are tools like CADA, so Kubernetes Event-Driven Autoscaler, which comes out of Azure Functions. It's kind of tangent to that, but you can run Azure Function apps inside of your Kubernetes cluster with CADA. So you can get a lot of that same capability that you would get with like Azure Functions. You can get that in your own Kubernetes cluster too. And if those things need to run as Windows containers, of course, then you can use Windows containers. Another thing would be for PowerShell scripts that need to run or jobs. You could containerize those and deploy those too. So it's so much more than .NET. And really the operating system becomes an implementation detail based on your needs. So legacy apps that are workloads or consoles or whatever, like that's a good way to isolate it and to deploy it. So, you got those kind of capabilities there, way beyond just web apps. I do have a blog post about how to enable ASP Classic to be deployed in an IIS container. So you could move your ASP Classic apps to containers and ship them, So you choose to do that or not. Nobody wants to admit they have ASP Classic, but if you did, like, you could ship it, and then you don't have all the weird complicated stuff of building a local dev environment, right? You just ASP files into a container that already has the feature enabled and you're off to the races. You don't have to worry about setting up your local IIS or anything like that. So there's lots of use cases, and I don't know, it's like, if you there's some differences in behavior, compared to Windows and Linux, and maybe the behavior of one fits your application better than the other. You've tested it in both, and so you want to deploy it, in Windows. Really, it's not so much. It's not so clear of a decision, really. I think it all depends on the app and the workload and what you're trying to do.
I'm trying to envision this in Kubernetes, right? Like I have never deployed Windows into Windows containers into Kubernetes, so that's an interesting twist that that I guess that's why I was so interested in this session is deploying Windows. What does that look like? Is it pretty much the same? Like where you deploy and you have a node pool and you simply assign your pods to the node pool, and the node everything else is handled by Kubernetes, like the pod fit and stuff like that.
Yeah, I mean it's pretty much the same way. Like if you look, your charts are not going to look all that different. So if you look at this daemon set here, like that doesn't look any different, right? The big thing is going to come into it is going to be you're going to give it a container that's a Windows container to run. You can see here we're mounting pipes from the host into the container. And so we can call a pipe or a gRPC service across from the container onto the host, which is kind of nice. And the biggest difference here is if you see here, we got these selectors or node affinities. The biggest difference is you need to set it to say, well, this is probably not the good thing, it's node selector here, but you need to set it to say, I want to be deployed on Kubernetes.io/Windows label. io./os:/Windows. Trying to find a good example of that that I have right here offhand. But basically, actually, yeah, I got my own repo too that I can go. Let's see here. I have a K8's AdventureWorks example that has the Docker file, uses Blazor. I have some manifests set up out here, and so you can see that the app, I have my node affinity set here, and I'm saying that only deploy this container or this deployment to nodes that their OS is Windows. And so if you're deploying things that are Windows only, you just give this node selector, this node affinity in here, and set it to only match for Windows or not Linux, right? Which might be kind of dangerous if there's other operating systems, which currently there's not. But so if you tell it to only deploy it on Windows with an affinity, then it will only schedule it to be on a Windows. Ideally, I would probably take the idea of doing a manifest and building both Linux and Windows if it could be built that way. But if it's just Windows only, then the way to go would be set the node affinity in your manifest or in your Helm chart to feed it in. And you can see here that I'm deploying, this is the app, and you can see here I'm deploying the database, and I have the node selector set on the node affinity set on the database to say only deploy on Linux, right? Because SQL Server can only run on Linux.
So in terms of being supported, like, there are various flavors of Kubernetes, right? Like AKS and EKS and so on. So which ones support Windows containers versus, or do all of them do that?
I'm pretty sure EKS announced Windows container support recently. AKS, of course, has Windows container support. That's been more recent.
Sure.
RKE1, so Rancher, RKE1, RKE2, both have Windows support. OpenShift, like I'm standard Kubernetes, right? Like you don't have to use somebody else's flavor. Like they all support Windows. So most of the major ones have Windows support. I believe GKE now has Windows support too. So most of them have Windows support. Now they're all at different levels with different technologies and different capabilities. So just kind of know that. That's something to keep in mind is looking at the feature set, looking at what's available, what's out there, and seeing if they have the features. Because right now, Kubernetes is making the shift from Docker Shim to just pure Containerd. So they're switching runtimes, container runtimes, and everybody's in a different place with what container runtime they're using right now and what they're going to be supporting. And keep a note. It's a good note for everybody here. Microsoft announced back in September, I think it was September, that or was it October? Sometime around the first of one of those months, they announced that they would be transitioning from Docker EE being on Windows to then moving to the Mirantis container engine and runtime. So they're shifting all of that Docker support partnership stuff back to Mirantis next fall. So keep that in mind when you're picking and choosing your technologies, that if you're trying to go with a pure Docker solution or using Docker today, that in the future you may have to go, if you want support, you may have to go with Mirantis, switch over to a support contract there. The details have been kind of a lot, but there's that blog post out there. So just know, because that the direction, if you're thinking about Windows, is really Containerd and stuff. And I think Azure's moving that way. Most everybody's moving that way now. There are other runtimes out there that other people are using, but Containerd seems to be the one that most people are moving to. So just kind of keep that in mind, that change is happening. So if you're trying to make decisions today, like you want to adopt Kubernetes, you want to go like try a bunch, ask those kind of questions, like, your solutions based on Docker today, what is it going to be? What's going to happen in a year? Do you support Windows Server 2022? If that's something you're planning on going to, that's still early days 2022 support. So that's something to keep in mind if that's the direction your shop's going, if you're doing Windows. And it's the same for Linux too, right? Like keep that in your mind too. Like if you need a paid support version of Linux, then that narrows down your choices quite a bit. And you just need to figure out what you're going to be comfortable with and who's going to give you the best set of features and things like that. So I wish there was an easy answer, but we're kind of in this transition period with Docker and stuff like that that's changing in Containerd with Kubernetes. So and the same for Windows containers too. So there's this concept called privileged containers in Linux, which a lot of like the container networking works as. Well, Windows is getting host process container support. The stuff's there to do it now. It's just all the distributions are trying to get those things implemented, figure out what path forward that is, when to go. So that changes a lot of capabilities in Windows setup in the future once those are more commonplace. So those are things to look for, and I know that's all really technical and a lot of words. So I think we got another question here about connections through NuGet packages with additional changes to be done. With FTP, I don't know. I don't think so. This is really going to come down to FTP is just a protocol over the network. So if your firewall and your network policies, if you're in stuff, should just work. Make sure that the network that Docker's using to run your container has connectivity to whatever network your FTP service is on. So if it needs to have access to the internet, then make sure you give it a network that has access to internet. Most Docker network setups, if you're just using containers, is going to be like a bridge network, and that'll give you access to all the same things the host has. That gets complicated though. That's a complicated question. In general, you should be okay. Another question about, is it better to host several applications in one container? You should really split them out into their own container. Think of one app, one container. A deployment to Kubernetes can have multiple apps in it if they got to work together. But really, you want one app per container in lots of ways. And if you decide to go Windows containers, or you're using Windows containers and you're concerned about the size, just know that stuff gets cached, right? So once you pull a server core image, all the layers that are in common are cached and get reused for all the other pulls that happen. So, that's another tip while we're on some of this conversation is that if you pick server core for a few things, you might want to use server core for everything. Like unit test project in a different, no, you'll want to put all of that in your build container if you're building inside the container. And you don't really want to ship that with your unit test anywhere. We could get into some advanced conversations about functional tests, and if you want to ship those as like a liveness check or like a smoke tests when you deploy your app to make sure it works before you say it's healthy, type of conversation. But that's possible too. Just while we're on that side note, there's these concept called init containers. So if you have some type of pre-configuration that has to happen, you can deploy an init container that will get deployed that runs at the initial start of stuff to kind of configure something that needs configured. And you could also do the same thing with like functional tests or health tests or whatever. There are liveness and readiness probes built in. I would encourage your apps to have those capabilities to provide that to Kubernetes or Docker to detect that the app is up and running. That's good to include, because then that way, your services can know. And that's the same if you're deploying to Azure, AWS. They both have those health check endpoints to check to make sure that your service is healthy and alert you if it's not. You should be making those and putting those in your apps. So that's really important. We have any other questions?
So yes, if no one else has any questions, where can we get the slides and code samples?
I will send you a link later, and you can post them on the meetup, or I can post them into the meetup. That'll be the best place for me to do. Is I'll just leave a comment with the link to the slides and a link to my K8 sample app, so you can see the Docker file and the manifests.
Okay, cool.
I also add a link to the Rancher masterclass that we did about Windows containers, which shows the app working there. So if you want something more to go off of.
Okay. Awesome. So, thanks for this talk. I mean, it was awesome. Learned quite a bit, especially on the Windows container side, in which I had zero knowledge. So, that this is really helpful. It kind of, I hold this user group kind of selfishly, right? Like it's on topics that I want to learn. So I invite speakers, and it's really awesome. So I don't know how many people are left, but let's see. We have about 15 people left. So I have three for the year, and for the end of the year meetup, I have like 3 licenses of JetBrains that I can raffle. So if you want to leave your name and email address, I can do a raffle, and if you win, I will send it to you. I promise not to sell your email address. We never do that at One Tug. So just type in your name and email address in the chat, and I will do the raffle and send it out after this call.
So Santosh, I don't think I have access to the chat because I'm connecting as a
Oh,
guest.
you don't have chat. Okay, good point. Good point. So let's see, what can we do? Is there an online notepad or something that I can spin on? Yeah, give me 1 second. Able to see chat now?
No, I don't think so. I can